Testing 1, 2. Morning, Tatu. Good morning. Just please switch on your mic or put the volume up. Can you now hear me? Can you hear me, Tatu?
Yes, sir. Hello, sir.
I almost ended the class because I didn't think you're going to pitch.
I'm always gonna pitch, sir.
You're late.
Yes, sir.
Okay. What are we busy with?
Last week, actually this Monday we're busy with the area rule, the
The
Cos
sun
Rule,
rule, the
and
cost rule. Have you now
yes.
completed that in school too? As
No,
well?
sir.
No.
Yes, sir. I haven't
Yes.
completed it.
Have you completed? Did you see any sums that you didn't find any values, but they just give you unknowns and you have to prove something?
Values like as in angles.
Yeah, like in thetas. Let me give you an example.
Okay.
Something like that.
No, sir.
Your textbook doesn't have any of those in.
Well, let me just.
Just quickly check, because if it's got it in, then I have to show you how to do it.
It's
It should
yes,
be
sir.
at the end
does.
of, pardon?
Yes, it is, sir.
Okay. I'm going to today show you how to do these examples. They are
Okay.
look much harder, but they're not that hard. If you look at the sum, it's like kind of scary actually. Okay. We're going to do 4 of them. And then if there's time left, we're going to do some other revision. But I want to show you a method how to do these sums. Now look at
Yes, sir.
Look at that triangle. Quickly redraw that drawing, and also right here, prove or whatever. Prove the following or whatever. Just prove that that's just make the drawing basically, and you're going to prove that AD is equal to whatever. Just do that drawing so that you have actually something to work.
Yes, sir. Yes. Why?
Prove that blah blah blah.
I'm doing the drawing, sir.
Yeah. Then there's also proofs of the sun rule, cos rule, and area rule in both acute and obtuse angles or triangles. That you should also learn. I'll show you what those are today.
Yes, sir. X, Y, Z.
Good.
I'm not done, sir.
Great. Okay. Now, I'm going to write you. I'm going to write a method down for you. You are going to struggle to understand the method, but as I do the sum, you'll exactly know what I'm talking about. The first step is going to be to start with what they ask. Start with what they ask. Second step is going to try and make the common side part of the sum, part of triangle 1. Step 2, make the common side. I'll show you now which is the common side. Part of triangle 2. And then solve simultaneously. So, the question is, prove that AD equals BE times sin Z times sin x plus y over cos x sin y. So AD is this angle here. Not angle, side here.
But
Right.
that is the common side.
No, that is a
side one.
side. That side can only be in this triangle. Can you see that?
Yes, sir.
The common side is the side that occurs in both triangles. So it will be this BD side. You see that?
Yes, sir.
BD occurs in both triangles, and that's the important side. So I'm going to start with what they ask, AD. Now, in AD, we can use that triangle, that green triangle. We can probably use the sin rule, because AD over that angle, which is sin of x plus y, equals BD. So I'm bringing in or making the common side part of the first triangle. So I started with what they asked, AD, and then I make that common side BD part of triangle 1. And now BD must be over sin of A. You understand how this works?
But I'm not getting it
Sin rule.
necessarily.
Remember,
It's kind
I
of
told you the
confusing.
sin rule.
Yes, sir.
AD on top of sin of that angle is x plus y, and then DB over sin of A. Now, what is A? Can you find the angle A?
The angle A.
Yeah, can we find that angle A? A equals, well, I can use this pink triangle here. It's not going to be so pink anymore, because I have a 90 degree in that angle and a small x. Can you see that?
Yes, sir.
So A is 180 minus 90 minus x, which is 90 minus x. And that's interior angles of a triangle. Over sin of 90 minus x. Good. Now I'm going to make AD the subject by multiplying right through with sin x plus y. Are you with me on this?
I guess.
Multiply both sides with sin x plus y, so it cancelled at the left. What is sin
Yes,
of
sir.
90 minus x?
Sir?
What is sin of 90 minus x? Isn't that cos x? Co-function.
It is cos X. Yes,
Yeah.
sir.
Okay, you have to know your work very well to do this. Okay, there we go. So now I've got AD. So I'm finished with the second step. Make the common side part of the first sum of first triangle. Now I'm gonna make the common side BD part of the second triangle. So now I'm gonna use BD over sin Z. And then I also have to do what? Make BE. Because BE is in the answer, so I have to incorporate BE over that angle there. Right, so I'm going to do BD over sin Z equal to BE, that has to be in the sum, over this little angle here, which I need to find. Can you find that angle?
Sir? Which angle, sir?
BDE.
Okay.
I'm gonna make it pink. That angle there.
So
Yes.
I think it's 45 degrees.
No. How do you know that? Damn. I don't have any degrees here. Can you see that BC is parallel to ED? Because these two angles are both 90 degrees.
Sir, I couldn't hear you.
Can you hear me now?
Yes, sir.
Can you see that this angle here, I'm going to make it yellow, is 90 degrees.
Yes, sir.
And the one at the bottom there is also 90 degrees.
Yes, sir.
So what do you know about BC and ED?
BC and ED.
They must be parallel
They are, sir.
because of alternating, no, corresponding angles. No. Is that correct?
Yes, sir.
So if they are parallel, then this angle here must be Y because it alternates with Y. So BDE is Y, alternating angles. So that's sin of Y. I don't think that your triangle work is as good yet as it can be.
Yes, sir.
Okay, so I'm going to make BD the subject. BD is the same as BE sin Z, because I multiplied with sin Z right through
Yes, sir.
over sin Y. And now I'm at the last step. I'm going to solve them simultaneously. So instead of a BD, I'm going to write that. So AD is then, instead of BD, I'm going to write BE times sin Z over sin Y. And then on top, there's another sin of X plus Y. And at the bottom, there's another cos X. Could you see what I've done?
Yes, sir.
I've just put that whole BD value in there. And then I've got the answer. So those 4 steps will solve about 95% of all these triangles. Okay, make your notes. Make note of those 4 steps. And then we're going to do another 3 examples with that same method, if possible.
Yes, sir. Yes, sir.
Good. Another one. Right. Okay. I'm just going to translate it. Prove that the area of triangle ABC is equal to root 3 QR sin Y over 2. Okay. I'm going to start with this triangle, obviously, yeah, ABC. And I'm going to actually just do the area rule there. So the area rule, area of triangle ABC. So I'm starting exactly with what they're asking. They're asking to prove the area of that triangle equals what? A half times AB sin C. Now, if that is your angle, then A and B are just the sides adjacent to that angle. So A might be Q and B might be AC, and then we have sin Y. Could you see that?
Yes, sir.
Good. So if I have a triangle here, and this is 30 degrees, and this is 10, and this is 12, then the area is half 10 times 12 sin 30. So it's half times the product of the two adjacent sides times sin of the angle between them. Okay, so now I've started there. I've also included this angle here, not angle side, which is common in both triangles. So now I'm going to just move to the second triangle and make AC that subject. So AC on top of sin 60 equals what? What other side? R. R has to be in the sum. So I'm going to use R over, and then I have to find that angle there on top there.
Yes, sir.
What is that angle?
We're trying to find AC, right?
No. Look at this.
Yes, sir.
AC on top of sin 60 equals
Yes, sir.
2R. Sorry, there we got 2R. It's not R. I don't know why I missed that 2. It's 2R on top of that angle there. What would that angle be? That's an interesting angle to find. Okay. It's an exterior angle to that yellow triangle.
Yes, sir.
Can we find that angle B? Or can we find this angle C here?
So, sir, can we just assume in math?
No, we can't assume. That's the last thing we can do. No science subject, you can assume anything.
Okay, so try angle ACB, right?
Yeah.
I think it's equal to 60 degrees.
How do you know that?
Because if you look at like the angle, just the one that's over AC, it's over like 60, right? So I'm thinking interior angles.
No, you can't. You don't know what that angle is. You have no idea what that angle is. This is a problem. This is a huge problem. Oh, I'm missing this R here. I can find AC on another method then. Nice. You can tell me how I can find AC then.
AC.
Yeah. I can use the angle, the triangle, the green triangle with a cos rule to find AC. Why? Because I have an included angle now. I have that included angle, that R and 2R. So AC square equals R square plus 2R square minus 2 times R times 2R cos 60. That's the cos rule.
Yes, sir.
You remember the cos rule? Do you want us
Yes,
to
sir.
actually go over the triangles again? Because I'm not 100% sure that you know your rules yet. That's 4R squared minus 4R squared cos 60. So that's 1R squared plus another 4R squared is 5R squared. Minus 4R squared and cos 60 is half. So that becomes 5R squared minus 2R squared. And that is 3R squared. That's AC squared. So AC is root of 3R. Because the R squared does have a root. So now I'm just going to pop that in there. And then I get the area of the triangle, ABC, as equaling half Q. And then AC is root 3 times R. And then sin Y. And what they did, they just wrote that half like this. 1 over 2. And then everything goes on top. Q goes on top. R goes on top. Root 3 goes on top. And sin Y. And then I have the same answer. That's proven then. Okay. I think we need to backtrack and just go over the sin, cos, and area rule again.
Yes, sir.
Otherwise, you're going to struggle with these. Okay, so I'm going to make up some new sums for you. And I want you to use the sin, cos, and area rule just to solve certain angles or sides. Okay, I've got a triangle here. Let's make it VFR. And this angle here is 46 degrees. And I have 11 meters here. Okay, that's not going to help a lot. I just want to redo it. Let's make this 46 and then let's make this Y side. And then I have 70 degrees here and I have 12 meters there. So I want you to solve Y. Or they could have said, what is the length of VR? Quickly do that. Write down the
Yes, sir.
do that. You need to become very good with these. Otherwise, you can't do those proofs. Because you're going to work slightly blind there.
Okay, sir. Okay. Equals. Y is equal to.
Or you can just explain to me what you've done also.
Yes, so can I just try to solve it now?
Yeah.
Almost done. All I'm left is to put this in my calculator. So
Yeah.
Y is 9,18606.
Very good. Very good. Okay. Y over sin 46 equals 12 over sin 70. Very good. So Y equals 12 sin 46 over sin 70. If you put that in your calculator, you get 9,19
Yes, sir.
meters. Good.
Meters.
Okay, good. So you can do that. Let's do Cos rule. So this angle here is 72 degrees. This angle here is unknown. It's Y. And this side here is 18 centimeters. And this side here is 12,5 centimeters. What is Y?
Okay, can I just can you give me time for me to write it down?
Yeah. Just want to test if you can do these.
Yes, sir. Okay. This is the Cos rule, right?
Yes.
Okay. Why is my um So I'm almost done, sir.
Yeah.
So y is equal to 18,47.
It looks right, yes. Y square equals 18 square plus 12,5 square minus 2 times 18 times 12,5 cos 72. You just type it in your calculator and you take the root of the answer. You were right. What was the answer? 18,
18,47.
yeah. Okay. Good. So now we go back to those proofs. Just did a little revision on what the sin rule. When do we use the cos rule? When we are given all three side lengths, or when we have an included angle. All
Yes,
other
sir.
sums, we're going to use the sin rule. Okay, there we go. They want to, you can quickly do that drawing. They want to know what is, want you to prove that xy, same as yx, that line equals whatever.
Okay, so can I just
Draw it, and
down
then
the...
we run through the steps, those 4 steps, and we try it again. And then you're going to do one on your own, and then we're going to do stuff if we have time left, other revision stuff.
Um, okay, sir.
Yes.
I am ready to start.
Right, let's go. Okay, we are going to start with the side that they're asking you to prove. And that makes it kind
XY.
of obvious. We must use this yellow triangle.
Yes, sir.
It's the only way we can. Okay. Right, so I have to include this side, and I also have to include the side that is common in both triangles. So this side over that angle there. Okay, that means we have to find that angle. And that angle is called what? XWY. And that equals 180 minus the sum of the other two angles, theta plus alpha. You agree with that?
Yes, sir.
Interior angles of a triangle. Good. So xy over sin of 180 minus theta plus alpha equals, we have to include the wy side because that is the way to move to the other triangle, and that will be over that angle there, sin theta. Okay, let's just fix this. What is sin of 180 minus theta plus alpha?
Sir?
What is this? Can you simplify that? That's second quadrant.
Yes, sir.
So that's positive for sin. So it's sin theta plus alpha. Remember
Yes,
this.
sir.
What is
Yes.
sin of 180 minus x. That is second quadrant, so it's positive sin x. X is just that theta plus alpha angle.
Yes, sir.
Good. And that equals wy over sin theta. Then I multiply right through with that. So xy is wy times sin of alpha, theta plus alpha over sin theta. I'm almost there if you look at the answer. Now I'm going to go to the other triangle. I have to include beta, but that's fine because that is the common one anyway. And I have to include this x here. So it's x over that angle there. I need to find that angle at y. Well, these two lines are parallel. So the sum of these two angles is 180 degrees. Do you agree?
Yes, sir.
Interior angles, no? It's not. It's not interior. It's not.
Doesn't it correspond?
No, it's not corresponding angles. It's not alternating angles. It's co-interior angles. So
Yes, sir.
beta plus alpha plus that thing at y there plus that angle there, which is WYZ, is 180 degrees. That is co-interior angles. So WYZ equals 180 minus those two, beta plus alpha. Good. So now I can use that. I'm just going to write it next to it, on the top there next to it. So I can use WY in the green triangle. Drop WY over sin beta equals X, which is the other side, over sin of 180 minus, well, they have alpha plus beta. We have beta plus alpha, but the same. We can write alpha plus beta. So WY over sin beta equals X over sin of 180 minus that angle is second quadrant. So it's positive sin alpha plus beta. So I simplify that. I get WY equaling X times sin beta over sin of alpha plus beta. And then I can pop into that WY. So therefore, XY equals, and instead of WY, I can write X times sin beta over sin of alpha plus beta. And then on top, I have another sin theta plus alpha. And at the bottom, I have another sin theta. And then I should have the right answer. I have it. Okay, happy? You gonna write it down? Tatu, can you hear me? Can you hear me, Tatu? Okay, then it's gone.
Sir?
Oh, you're back.
Yes, sir.
Okay, you disappeared for a second. Quickly write that down.
Yes, sir. sine b. Yes, I'm done.
Okay, good. Right. Fourth one. I'm going to leave this one for you to try on your own. Okay.
Yes, sir.
Right. So SR, that makes it easy to know what triangle that is.
Yes, sir.
And you also have to get P into the sum. Try and follow those steps.
Yes, sir. P Y. S and
You can ask me some help if you want to, but it'd be nice
yeah,
if you try and do it on your own.
yes, sir. I'll do it. Okay. Given the sign. So okay. Um okay. This is sir.
Yeah, you got it.
Okay, since no, I wanna ask you.
Okay. Yeah. You started with SR. Tatu. I can't hear you.
So I'm like the first triangle is SQR.
Moi. Very good. Very good, very good. So you started with that triangle.
Yes, sir.
Good. And then you said SR is what I want.
Yes, sir.
So SR on top of that angle there, which is 90 minus y, isn't it?
Yes, sir.
Sin of 90 minus y. And that equal, this is an important side because it transitions from the one triangle to the other one, which is QS on top of that, which is sin Z. Good. Did you get that? I'm just going to simplify here. 90 minus y, sin of 90 minus y is the first quadrant, so it's positive. That becomes cos y. Co-functions. Did you do that? Tatu, did you actually change the sin 90 minus y to cos?
Yes.
Good. SR equals QS times cos y over sin z. Right, now I need to get QS in the second triangle. Okay, did you struggle here?
Yes, sir.
Okay, so let's do QS. QS, let me just get a better pen. QS on top of angle P. P is 180 minus x plus y. Interior angles of a triangle. Did you see that? Can't hear you. So that angle is 180 minus the sum of these two. And then I have to bring P into the equation. P over sin x. So QS over sin of x plus y equals P over sin x. So now I've got QS. QS equals P times sin of x plus y over sin x. And then I'm just going to substitute. So SR equals then QS is P times sin x plus y over sin x. And then I also have cos y at the top. And I have a sin z at the bottom. And there's the answer. Awesome. Can you hear me now? I can see you talking, but I can't hear you. I think
So I'm not talking.
you're not talking. Okay. Look through that and tell me where you've actually stumbled.
Okay.
Did you do this conversion?
Sometimes, sir, it confuses me, the conversion, sir.
Remember those? Okay, so write this down and then we'll play around with those examples.
Yes, sir.
Tell me when you're ready.
I'm ready, sir.
Okay, good. So what you're struggling with is the following. So let's simplify cos of 180 plus x. Can you help me there?
Okay, so since that's like in the third,
Third
not the
quadrant?
third. It is in the third quadrant, sir.
It is. It is the
And
third quadrant, yes.
in the third quadrant, it is 10. That is positive. So it's going to be negative sign.
Negative cos x. Agree. Is that right, Tatu?
So yes, I'm going to say negative cos x, yes.
Yeah. Okay, but now if I have this, cos of 180 plus alpha plus beta, it's the same. Alpha plus beta is now just in the place of x.
Yes, sir.
So that's also negative cos,
Negative
and
cos.
instead of x, I have alpha plus beta.
Beta, yes, sir.
So you have to do those conversions. So if I have
Oh,
sin of 180 minus x plus y, that's the same as positive sin of
sin
x
is
plus y.
x plus, yes.
And those are the things you're not getting right in those triangles. Okay. Happy. Are you happy? Let's do one more. And then we finish
Yes,
with
sir.
this book. We're not going to do any more of these. Because they're not that important, to be honest. The reduction values we've done are more important.
Yes, sir.
Okay, so we do easy one. Well, it looks relatively easy. I'm just going to copy and paste it. Right. So they're starting with BC.
Yes, sir.
Now, BC is the common side in both triangles, in the smaller BCD one and the BCA one.
Yes, sir.
So I'll probably have to use both. I can decide which one I want to use first. Doesn't matter. What is nice about these two triangles? They have 90-degree angles in it. Okay. I don't know if that's going to help a lot. But if I look at this small yellow triangle, I can do what?
Were you just speaking because I didn't hear you?
What is nice about these two triangles, they both have a 90-degree angle in it. I have to use this side, and I have to use that side. So I can start by saying just cos y is adjacent over hypotenuse. That's just normal grade 10 trig, because I have a 90-degree angle in there. I can also use the sin rule if I want to, but sin of 90 is 1, so it will just cancel.
Yes,
So
sir.
BC equals BD times cos y. And now I have to use BD in the other triangle. Okay, now I've got a small triangle at the top, which doesn't have a 90-degree in it. Now you have to take the sum forward on your own. You can write it down, write everything we've done, and then you use BD in the second triangle, which is a small one on top.
Um, equal to BC over BD. Therefore, BC is equal to BD.
Cos y.
Um,
sorry, a coefficient is a number that is before the variable.
so
Yes, got it.
we're trying to calculate BD, right?
Yeah, BD in the top triangle.
Yes, sir.
So I'm going to use the sin rule. BD over sin of this angle here at the bottom.
Yes,
That
sir.
angle at the bottom is x minus y. You see that?
Yes, sir.
And that equals h over, no, it was a wrong angle, that one. BD was over, look at me, over that angle there. So it's over A. I'm just going to take this yellow out. Oh, the blue, that's better, and the yellow. So BD is opposite that angle there, which is angle A. And angle A is easy to determine. It's 180 minus this 90 minus this big angle here, which is x. So that is 90 minus x. Sin of 90 minus x. And h is opposite this angle here. So it's sin of x minus y. Great, not difficult. BD over, then sin of 90 minus x is cos x, co-function. And that is h over sin of x minus y. So BD equals h times cos over sin of x minus y. And then I'm just going to pop in there. And then on top there, I have a cos y. Okay.
Yes, sir.
I'm sending you work on this. I'll see you next week.
Yes, sir. I'll see you next week.
I did send something on dates that we have in classes, eh?
Yes, sir.
Okay.
Bye, sir.
Bye-bye. Keep well.
Keep well, sir.